Alright, no matter if you have a binomial or a trinomial or four more terms, the first thing you always look for is there a greatest common factor? With four more terms, you use grouping, and those two things we've already talked about. We have done two special cases. There's two more we're going to add later, but we have done the PST, perfect square trinomial, giving you the binomial squared yesterday. We did that, and the difference of two squares gave you conjugates. So we're down to winding up here. If you have a trinomial, we will use trial and error tomorrow, or probably Monday, right? Come back and do bottoms up just to show you that. Trial and error, by the name, tells you will try, you will make errors, you will sometimes erase more than you write, and come back and figure out if you got the right answer or not. The way you check that is by using the FOIL method, and I'll show you what I mean in just a few minutes. If none of these things work, then the problem is not factorable and is therefore called prime. Now that does not mean it doesn't have an answer. That just means you can't use the factoring method to do it. So we're going to start out really slowly, like baby steps along the way, and every example I give you will be just a little different from the last. But this is a quadratic trinomial, which means what? Quadratic means it's got an x squared, and it's a trinomial, so there are three terms. Okay. If this is the opposite of the FOIL method, then that means that I should get two binomials as my answer. One good thing I always like to see in a problem is that when this last term is negative, that tells me that my binomials will have like signs. Now, will they both be positive, or will they both be negative? Depends on what's here in the middle, because whatever is in here in the middle, I bring down to both binomials when I have like signs. Now I have 1 as my leading coefficient, the line leader, right? The one that comes first is 1, and that's good, because that makes these problems a lot easier. As we go through the lesson, this is not going to become 1 anymore, but for right now, this is a 1, and this 10. All right, I'm going to think of all the factors of 10, and there aren't many. Now, some of these problems, like we were talking about earlier, you can do in your head. You know, factors of 10, you know those. If this was a 252, a 36, something with a lot of factors, it might serve you to actually physically list them just so that you can see, because most of us do learn by sight. We see it, we understand it. Okay, so you use this at your discretion if you need to make that list or not. All right, what times itself is x squared? X. Now I need to use factors of 10 that when I FOIL with outer and inner, I would add, because I have like signs, I would add to give me this middle. So would it be 1 and 10 or 2 and 5? Which of these would I add to get 7 but multiply to get 10?
2 and 5.
2 and 5. Let me show you what I mean. Of course, if I do first, that's x squared. If I do outer, it's 5x. If I do inner, it's 2x. When I add those together, I get the middle here. And then, of course, last would be 10. So by checking, I know that this is my answer. Now, if someone in the class had written down their 5 here, and there are 2 there, would they be okay? Yes, because x plus 2 and x plus 5, by the commutative property, I can multiply them in any order, right? They've got the same sign, the same variable in there anyway, right? All right, let's look at this one. M squared minus 5m plus 6. There's not a greatest common factor. This is definitely not a perfect square trinomial, because this is not a perfect square, right? So that's how I know I'm going to use trial and error. This tells me that I have like signs. And this tells me that they will both be negative. What goes here and here? What times itself is m squared? Right. Okay, I need factors of 6. Numbers I multiply to get 6, but add, because I've got these like signs, to give me 5.
2 and 3.
2 and 3. And if you wrote 3 and 2, you're just as good as this, okay? Now remember, first is m squared, outer is negative 3m, inner is negative 2m. If I add those together, I get the right number in the middle, and then last is plus 6, so I know this is the right answer. Remember, trial and error. We're going to try, see if we made an error. If we did, we will correct it. If we don't, we circle it, right? It's the answer.
I think I got this now.
But this is going to get more complicated,
Yes, it
okay? As
will.
every problem is a little bit more, or is a little different. I won't say a little more difficult, a little different. What is the difference in this problem and the problems we have worked till now? This was not in what order?
Descending.
Yes, right. It's not in descending order. It is in ascending order. And so if we were going to write this in descending order, I would have my positive a squared, my negative 8a, and my positive 12. You could factor it the other way, but it's probably easier to factor it in descending order. Alright, so my two binomials. Alright, you tell me, what signs will go here and here?
Negative.
That's right. They got like signs, thankfully. If that last term is positive, that's a good thing. We got like signs. Alright, what goes here and here?
A.
Good. Alright, 12 has a few more factors. We have 1 and 12, 2 and 6, 3 and 4. Which of those factors would I multiply to give me 12 but add, because I've got like signs, to give me 8?
2 and
2 and
6.
6.
And if you FOIL that back out, you get the problem. Because outer and inner give me negative 8. Now we're still doing the really easy ones. Does anybody have a question so far? Alright, let's look at this one. How is it slightly different than the rest?
12b is squared.
You have two variables in this problem, right? There's not a greatest common factor. This is not a perfect square, so it can't be a perfect square trinomial. What signs go in both binomials?
Plus.
This tells me like signs. The middle tells me I'll have positives. Okay, what goes here and here?
A.
A.
When I think about my factors of 12 again, I need factors you multiply to get 12, but that you add to get 7. 3 and 4. And not only would I put 3 and 4, but I also have to have what with them?
B.
A B. Yeah, B with each one. So if I do first, I get a squared. Outer is 4ab. Inner is 3ab. If I add those together, I get the middle term, which is what I wanted. And then last would be 12b times b would be b squared. That's my answer. I need you to try these 5. Okay, if these are the answers, does anybody have a question? What if on my paper I wrote x plus 9 and x plus 1? Y minus 11 and y minus 2, that's the same thing, that would be. Okay, let's change years. This is supposed to be a 1 here. It's not very good at that. I don't know, I can't seem to fix it. Just get rid of it, actually, I guess. I'm just trying to point out that we still have a 1 as linear coefficient anyway. What is the difference in this problem and all the ones we've done today? There's-
Signs are different. The second one is a negative.
Yes, because this, actually it's the third one, right? 'Cause this is positive, positive. So this tells me different signs. And you say, well, which one's which? Because it does matter. It does matter what number goes with what sign. But here's where we might mess up and have to come back and fix it. But we have an eraser ready. All right, what goes here and here?
That's positive. So it doesn't X.
When I think about factors of 10, there aren't many. But now instead of adding to get 3, because I have different signs, I will subtract to get 3.
So 2 and 5.
Yes. Now don't copy this down because I'm going to miss it on purpose, okay? I'm missing this on purpose to show you something, making a point here. If I do outer and inner, I get the right number but the wrong sign. Okay, I need it to be positive. So anytime you're working a problem where you get the right numbers but the wrong signs, all you have to do is switch your signs. Because a positive 5 and a negative 2 gives me a positive 3. Okay? Now the plus has to go with the 5. The negative has to go with the 2. But if x minus 2 was over here and x plus 5 was over there, that would be okay. But what's not okay is x plus 2 and x minus 5. Does that make sense? The sign has to go with them. Okay, here's another one. Not a greatest common factor. This is not a perfect square trinomial. The special cases. Okay, again, this tells me different signs.
Wait, so it doesn't matter which order you put them in?
Not at all. Not at all. You can put the negative first. It doesn't matter. So I'm going to put the A here, A there. Think about the factors of 24, and there are several here. Alright, now I need factors of 24 that I would subtract to get a negative 5. Which ones would you pick? Which one?
8 minus
8 and 3. Alright, now let's use common sense. If I have to get a negative 5, and when you subtract, you always take the sign of the bigger number, right? What goes here? The 8. So first is a squared, outer is negative 8a, inner is positive 3a. Did it work? It did, okay? And then last is negative 24, there it is. That's why we're kind of taking baby steps, because if I'd have mixed all these together, you guys would have been like, what's the signs and where, which way goes which? So we're just trying to go a little at a time. That's why we're not even using our textbook today. All right, this problem is different because I've got a negative here and I have two variables. All right, so I have different signs. I have the m's. I've listed the factors of 14. Which ones subtract to give me 5? Go ahead and say, y'all know it. 2 and 7. All right, which one needs to go with the negative?
The 7.
7. But 7 doesn't go by itself because I need an n squared at the end, right? So this would just be what?
N.
7
N.
n, and this would be
7 N. I mean, not 7 2.
2n. You're right. Because when I pull that out, I would get 2mn and negative 7mn, and that would be my negative 5mn that I needed. Honestly, what I miss on these is I forget that at the end. I'll get concerned about what the numbers would be, and I'll forget that. So double check and make sure if you have two variables in the problem, you have two variables in the answer. All right, these are the practice problems. Oh, I've got that. Okay, I need factors of 12 that I would subtract to give me negative 1. What would they be? M minus, do y'all know the first one?
4.
4. And M plus
3.
3.
I did backwards there.
That's okay. If you did M plus 3 and M minus 4, you're okay. Just make sure the minus is with the 4 and the plus is with the 3. Alright, let's look at number 2. I need factors of 6, and there aren't many of them, that I would subtract to get me a negative 1 in the middle. So I need 2 and 3. And which one needs to be negative since the middle's
3
negative?
needs to be negative.
And I need what with it for this? for y squared, what do I need with it?
Y.
Oh, y. Number 3. Alright, I need factors of 27. 1 and 27, 3 and 9. And I need to subtract those factors of 27 to give me 6. So it would be a plus
3B.
and a minus,
9B.
because negative 9ab and positive 3ab is negative 6ab. How are we doing? Alright, so I'll have different signs again. Alright, I need factors of 8 that I would subtract to get 2.
2 and 4.
Okay, so the 4 needs to be positive and the 2 needs to be negative to get me a positive 2 in the middle. Now when you get to 52, you got 1 and 52, 2 and 26, 3 and 14. Is that it?
4 and 13.
Yes. So negative 14b and positive 3b. But here's the deal. I mean, until you make your list, you probably would. You might not think of 3 and 14. You know. Whoops, what's part of that? Okay. There are only 2 factors of 3. It is a prime number. I know I'm going to do 3 and 1. What goes where?
3 goes on the plus sign, and 1 goes on the negative.
Because positive 3 and negative 1 give me 2, right?
Yes.
Okay, factors of 54
1,
that I would subtract give me 3, huh?
1 and 54.
Yeah, I got 1 and 54.
26 times 2.
2 times 27. Yep.
Oh,
3
27.
times 18. 6 and 9. So R plus
9.
9 what?
T.
And R minus 60. The only way we'll get good at that is just to practice and practice, okay? Alright, the last type is like this. I no longer have 1 as a leading coefficient. So now I have to think about factors of 2 and factors of 5. Okay. Now remember, we've got to FOIL to get the problem back. There's only one choice for 2. I've got to have a 1x and a 2x. Now I'm just going to take a chance here because that's all I can do, and just put down some signs. I know they're going to be different because of this. Now I'm going to put down my 1 and my 5. I'm going to miss this on purpose for you just a second. Watch this. What does this give me in the middle?
7x.
I have a multiply.
Yeah.
10, negative 10, and positive 1 would be negative 9, wouldn't it? So only switch one thing at a time. Don't switch out the 1 and the 2 and the 5 and the 1 because you get back in the same order again. So let's just switch these around. Let's put the 1 there and the 5 there. What about that? Does that work?
5x.
5x minus 2x. What do you do when you have the right number with the wrong sign?
Switch them.
Just switch the sign. Switch only the signs. And so this will become positive and this will become negative, and a negative 5 and a positive 2 is a negative 3, and it works. You see all the trial and error? I try. I mess up. It's okay. I just try something else and keep moving it around. Okay, let's look at this one. A 6 is not a prime number, but at least 3 is. Now, I always say I have this little rule that I look at my I look at my choices, okay? And I'm trying to get a 19 here, y'all. And so what is 6 times 3?
18.
That's really close to 19. And so I think instead of starting with this 2 and 3, I'm going to start with this 1 and 6. And I tell you, got some good news right here, right? What does this tell me?
They're like
Like
signs.
signs. And they're both positive. All right, I've got to do 3 and 1. What will I put here to multiply by the 6? Which is very close to 19.
3.
Let's see if this works. Outer is 1x. Inner is 18x. If I add them, got it, right? There you go. So I just added a whole new dimension when I got another number over here to work with. Okay. All right, here we go. Compared to these two numbers, this middle number is really small. So I picture these numbers on the number line. And if this number is really small, I want to start with factors that are close together on the number line. I mean, picture you got 1 here, 6 here. But on the number line, 2 and 3 are what? Right together. Look over here. What do you think? If I'm going with that rule about being close together on the number line, what do you think you would use over here?
3 or 4.
All right, so let's see if we can pair those up. Now I'm going to have different signs. So I'm going to have a 2x and a 3x. And I just put my signs down, okay? I don't know. If you're lucky, you'll get it right the first time, you know. And eventually, actually, I mean, I know I've got this backwards. But eventually, you'll know that too, okay? So if I put, I'm going to miss this on purpose, all right? What if I do this? What do I get? 12 minus 6, right? Is that it? Okay. So let's switch these up. What do I get? Negative 8 and positive 9. Am I okay? What's wrong?
Signs.
So what do I change?
The signs.
Signs. So a negative 9 and a positive 8 gives me my negative 1. Got it. So my rule worked about if this was small, then I want to try to use factors that are really close together on the number line. Okay. Now that's not always going to work, but I mean, it just kind of makes common sense that if you subtract numbers that are closer together, you're going to get 1. Does that rule apply to this? I mean, compared to 4 and 15, 59 is pretty large. And so would I want to use numbers that are close together or further apart?
Further apart.
All right, do you know, let's look at the factors of 15. Let's look at the factors of 4. All right.
Here's somebody sitting there.
Yeah. All right, we'll do the rest tomorrow.